All right, let's tackle something that trips a lot of people up in networking. How do you take one single block of IP addresses and chop it up into 4 different networks of 4 completely different sizes? It sounds kind of complicated, right? Well, by the time we're done here, you're not just going to get it. You're going to see why it's actually pretty cool. So let's jump in.
So, imagine this. Your CEO from Hackwell Industries walks up to your desk. They've got a mission for you. You're in charge of designing the network for a brand new factory, and they've just handed you a list of very specific non-negotiable requirements. No pressure, right?
And here's the request. We need 4 totally separate networks. First, one for the human workers. That's 117 people. Then, a network for the 57 factory robots. Another one for the 26 servers, and finally, a small guest network for about 10 people. The real kicker? You have to build all of this using just one starting network, 172.21.42.0/24. So how on earth do you make that work without wasting a ton of addresses?
Well, the magic trick here has a name. VLSM. It stands for Variable Length Subnet Masking. You can think of it like this. Instead of cutting a pizza into 8 equal slices when maybe you only want a tiny sliver, VLSM lets you cut each piece to the exact size you need. It's the perfect tool for solving our CEO's challenge.
Okay, now before we even touch a single number, there is one golden rule you have to burn into your brain. If you remember nothing else from this, remember this. With VLSM, you always start with the biggest network requirement and work your way down to the smallest. Always. No exceptions. Got it? Big to small. That's the entire secret sauce right there.
So here's our game plan, and it's super straightforward. First, we list our needs, which are already nicely sorted from largest to smallest for us. Perfect. We're going to figure out the subnet for the biggest network first. Then, and listen up, this part is crucial, we find the very next available IP address, and that becomes the starting point for our second biggest network. And we just keep doing that over and over until every network has its own little home.
All right, enough talk. Let's actually do this thing. Following our golden rule, we have to start at the top of the list with the largest requirement, and that is the workers network, which needs space for 117 hosts.
So, 117. That's our target number. We need to carve out a chunk of addresses that's big enough for 117 different devices. You know, all their computers, their work phones, the whole shebang.
So how do we find the right size for that chunk? It all comes down to the powers of 2. We're looking for that just right fit. Not too small, but not too big and wasteful either. Okay, let's see. 2 to the power of 6 gets us 62 hosts. Nope, that's not going to work. How about 2 to the power of 7? That gives us 126 usable hosts. Bingo, that's our winner. It easily covers our 117 hosts with a little room to grow. This tells us we need to save 7 bits for our hosts. Now remember, our original /24 network gave us 8 bits for hosts. Since we've decided we only need 7 of those bits for our worker devices, what happens to that leftover bit? Well, we borrow it and we give it to the network portion of the address. And that one little change turns our subnet mask from a /24 into a /25. And just like that, our first custom-sized network is born.
So let's see what we just made. Our brand new workers network starts at 172.21.42.0. And because it's a /25 mask, it uses up all the addresses right up to 172.21.42.127. Now, this is super important. What's the very next address after that? It's 172.21.42.128. That's not just a random number. That is the starting line for our next subnet.
Okay, 1 down, 3 to go. And the really good news is, you've seen the whole process now. We're just going to do the exact same thing for the other 3 networks, just with smaller numbers. So let's pick up the pace a bit. We'll call this the speed round. Next up on the list, the robots.
The robots need room for 57 hosts. So let's run our powers of 2 again. 2 to the power of 5 is 30. Nope. 2 to the power of 6 is 62. Perfect. That's our number. So we need 6 bits for hosts, which translates to a /26 subnet mask. That gives us a nice block of 64 addresses for our robot army.
You're seeing the pattern now, right? It's the same dance every single time. Next up, 26 hosts for the servers. Let's see. 2 to the 4th is 14, too small. 2 to the 5th is 30. That'll work. So 5 host bits means we need a /27 subnet mask, which carves out a block of 32 addresses for those servers.
Easy peasy.
And last but not least, our little guest network. They only need 10 hosts. 2 to the power of 3 is 6. Nope. 2 to the power of 4 is 14. Perfect. Just right. That requires 4 host bits, so our final subnet mask is a /28, a nice, cozy little block of 16 addresses. And that's it. All our calculations are done.
And just by sticking to that one simple big to small rule, we did it. We've met every single one of the CEO's requirements. So now let's stand back and admire our handiwork. Let's take a look at the final network map you've created for Hackwell Industries.
And check this out. It's beautiful, isn't it? Look how cleanly it all fits together like a puzzle. The workers' network ends, and the very next address is where the robots' network begins. No gaps, no wasted space. We've got the /25, then the /26, the /27, and the /28, all lined up perfectly in a row. It's just so satisfyingly organized.
I mean, let that sink in for a second. We just took one big, generic chunk of a network and skillfully tailored it to 4 unique needs with absolutely minimal waste. This isn't just a neat math puzzle. This is a core skill for designing smart, organized, and scalable networks.
And you know, as Network Chuck, who inspired this explainer, would say, I can confidently say you no longer suck at subnetting. And he's right. You just took on what is probably one of the most feared topics in all of networking, and you totally crushed it.
So, what are the big things to remember here? First, VLSM is your absolute best friend for being efficient. Second, the golden rule. Say it with me. Largest to smallest. Third, remember the subnets have to be back-to-back. No empty space between them. And finally, and this is the real big picture stuff, this is about way more than just saving addresses. This is how you create logical order and security for your network. It's an absolutely essential skill.
You now have this incredibly powerful skill in your back pocket. You hold the blueprint to design efficient, secure networks right from the ground up. So the only question left is, what are you going to build with it?
Thanks for sticking with